Hi everyone, Mr. Mark here. The purpose of today's video is to run through a few examples for inflation for the Year 12 General Math course and the financial modelling topic in particular. We're going to be looking at indexation in one example and also the real rate of return on investment when you consider inflation. So what, first of all, is inflation in simple terms? As it says here, inflation is the general increase in the price of goods and services over time. So you can imagine the price of things like bread, milk, petrol increases over time. So that's basically what inflation is, the price of things going up. But what inflation does is it actually reduces the purchasing power of your money, because a fixed amount of money, say $100, will buy less goods and services as prices rise over time. So for example, let's look at petrol. If I have $100 today, the amount of petrol I buy today will be less than what I can buy or what I could have bought, say, 10 years ago. $100 of petrol today is more than it will be in, say, 10 years' time. So that's basically what inflation is: the increase in price of goods and services over a period of time. It's usually given to us as a percentage increase, an average percentage increase over the course of a year. Okay, so looking at the first example, we're going to be focusing on indexation. Indexation is kind of like the adjustment of the price of something, taking into consideration the rate of inflation. Okay, so first example, he says Georgia would like to purchase a painting that is currently worth $5,000. She makes monthly deposits into an investment account so that she can purchase the painting in 3 years' time. Now, with the idea of inflation, we'd expect the value of that painting to actually increase in 3 years' time. So it would cost more than $5,000 in 3 years' time. It says here, if inflation averages 2.5% per year, calculate the value of the painting indexed for inflation for 3 years' time. So she wouldn't actually need to save $5,000. She'd actually need to save a little bit more, because we'd expect the price of that painting would be more than $5,000 in 3 years' time. So what is the indexed value of the painting in 3 years' time, considering an average inflation rate of 2.5% per year? So what we're going to do is we're going to increase $5,000 by 2.5% every year for 3 years, but it's going to be compounding, okay? So to do that, what we're going to do is we're going to, first of all, convert our 2.5% to a decimal, which is 0.025. Now, I'm not just going to multiply $5,000 by 0.025, because there I'm only working out 2.5% of $5,000. I want to increase the $5,000 by that 2.5%. So I'm actually going to multiply it by 1.025. I'm multiplying 5,000 by 102.5% essentially. Okay, so it's $5,000 times by 1.025. That would be the index value of the painting after 1 year. But because it's 3 years, we're raising that to the power of 3. And that's it. That's how you calculate the index value of, in this case, the painting, which costs $5,000, based on the inflation of 2.5% in 3 years' time. So on your graphics calculator, just within the run function, you can do this one, guys. Head in and do that calculation, which in this case is 5,000. Oops, let's just open up this a little bit more. Sorry, guys. So 5,000 times by 1.025 raised to the power of 3. Okay. In this case, it's telling us the index value of the painting is $5,384.45. So $5,384.45. So you'd expect that you'd expect that in 3 years' time, Georgia would need to actually pay $5,384.45 for the painting, but at the moment costs $5,000. Question B says the investment account she's putting money into, pays 3.5% per annum, interest compounded monthly. How much will Georgia need to deposit into the account at the end of each month? So basically working out her PMT, how much she needs to pay into that account per month to get this amount, $5,384.45. So that will do that within the compound interest section, the finance function on our graphics calculator. This is something that's pretty repetitive, but I will go through it for the sake of this video if you haven't done that before. We will be putting in these values. I'll just quickly show you, and then we'll write them down before we go ahead and do them. So we need to put in N as in the number of compounding periods that the money is going to be invested for, what the interest rate is, what the present value is, PV, what the payments per term is, what we're actually trying to determine, what we're working out, what the future value will need to be, and payments per year and compounding periods per year underneath that as well. So starting off with N being the number of compounding periods, well, it's 3 years she's investing the money for. It's compounded monthly, so 3 times 12 or 36. The value of the I, or the interest rate here, is 3.5%. And again, on your graphics calculator, put it in as 3.5. Don't change that to a decimal in this case. The present value, let's just say that she's starting with 0. PMT is what we're actually asking the calculator to work out for us. So how much does he have to pay every month in order to save that amount? The future value that she wants to achieve is the $5,384.45. The payments per year, in terms of the compounding payments per year, will be 12 because it's compounded monthly, and compound periods per year is also 12. So let's go ahead and put those values into the calculator and ask it to calculate PMT for us. So on the graphics calculator, enter in 3 times 12, or you can enter in 36 straight away. The interest rate, as we said, is 3.5%. The present value, we're going to start with 0. PMT is what we're asking it to calculate for us. The future value, we want it to be $5,384.45. Now, this is going to be a positive value because we're actually looking to withdraw this money. And this is the money that we'll have access to purchase the painting in 3 years' time, or Georgia will at least anyway. PY and CY will remain here as 12. So then we just ask it to calculate PMT by pressing F4. Will tell me that she will need to deposit, and that's why it's a negative value, because she's putting money, or she's giving money to the bank there, $142.07 each month for 3 years in order to achieve her goal. All right. So PMT basically is $142. Sorry, I'll get rid of that. $142 and 7 cents. Now, for the sake of the question of this video, trying to keep it as short as possible, I'm just writing it there, but you would hopefully write that in a full sentence. Therefore, Georgia would need to invest $142.07 every month for 3 years in order to achieve her goal of purchasing that painting at the indexed value. The next example that we're going through here is looking at, in particular, the real rate of return of an investment. Okay, I'll talk a little bit about that when I get to that question. First of all, let's go through the basic steps. $10,000 is deposited into an account for 3 years, 5.4% per annum, interest compounded monthly, inflation over the period averaged 2% per year. First question just asks us to calculate the value of the investment after 3 years. So there's no need to consider inflation in the first question here, but we do need to look at the number of compounding periods, which again is 3 years compounded monthly. So it will still be 3 times 12 or 36. The interest rate this time is, as a percentage, 5.4%. Present value is actually, so the starting amount is $10,000. But again, when we're putting it into the graphics calculator, because we're giving it to the bank, we're paying that amount in, it's minus $10,000 for an investment. PMT is going to just be 0 for the sake of this, because it doesn't look like, in this case, there's any regular monthly payments. The future value is actually what we're asking it to determine for us. What will it be worth in 3 years' time? And PY and CY, again, will both be 12 because it is being compounded monthly. So go ahead and put those values into the graphics calculator and ask it to calculate the present value for us. So to do that, just change those values. N can stay as 36. The interest rate will change to 5.4. The present value becomes minus 10,000. PMT, there's not going to be a regular payment. The future value is actually what we're asking for the answer to be, and PY and CY will both stay as 12. So once you've got those values in, go ahead and ask it, what will the future value be after 3 years? It will be $11,754 and let's go 33 cents. $11,754. $11,754.33. That will be the future value in 3 years' time. Okay, it says find the value of the original investment index for inflation. So we're going to adjust that original $10,000 and index it for the inflation of 2% per year for 3 years. Okay, so similar to what we did up here. Okay, first of all, we're going to convert that 2% to a decimal. So 2% becomes 0.02. Okay, then we're going to multiply that by the present value or the principal that we're investing. But again, we're going to multiply it by 102%. So it becomes 10,000 multiplied by 1.02 to the power of 3 because it's 3 years. Okay, and this will tell us the index value of that $10,000 in 3 years' time based on inflation average of 2% per year. So again, back within our run function, you can do that one. So it becomes $10,000 this time, times by 1.02, again to the power of 3, which in this case is $10,612.08. $10,612.08. So basically what that means is that based on those numbers, 2% inflation per annum or per year for 3 years, that $10,000 today, for example, would have the same buying power as $10,612.08 in 3 years' time. Okay, so let's look at part C, where we calculate the real rate of return of the investor or on the investment. So what is the real rate of return? So this is how we're going to work this out. We're kind of going to look at the present value now actually being $10,612, and look at how that will change what the actual interest rate is. So we'll go back into the financial function there, and within compound interest, we're going to just make N3 for 3 years, and we're going to change, let's go ahead and just change PY and CY to just 1, because we're talking about a percentage increase per year. So just 1 increase per year in terms of the 2% increase. Now, for 3 years, that is, and the present value now actually becomes the indexed value, which is minus $10,612.08. And then we're going to ask it to calculate the interest. So this will be the real rate of return. Okay, so the interest rate is now actually 3.46 or 3.47%. Okay, so for C, it's an interest rate of 3.47%. Now I know the interest rate was actually 5.4% when the money went in, but essentially because the purchasing power of that $10,000 has decreased over the 3 years. It really has only worked out to be an increase of 3.47%. Okay, considering that the purchasing power of $10,000, today or 3 years ago, however you want to look at it, has become $10,000. You need $10,612.08 to purchase the same goods and services as you would have now or 3 years ago. Again, okay, looking at how you sort of read that question. So sorry about the confusion there, but that's pretty much all we'll be looking at in terms of inflation in this course. There will be some trickier questions, obviously, but yeah, the more you practice these questions around inflation, the better you get. This is how you index the value of a product or the value of money based on an average inflation rate for a certain number of years. And that last part I showed you is how you calculate the real rate of return based on indexation of the initial principal or the initial amount that you invested, taking into consideration the inflation. Okay, so what actually is the real rate of return? All right, hopefully that helps. Thanks for watching, and I'll see you in my next video.